Hi everybody, this is Mr. Short. Today we're going to learn how to draw Bohr atomic models. We'll take a look at two neutral atoms and one charged ion. The first thing I want to teach you is that when you're drawing a Bohr atomic model, you actually start by writing a complete electron configuration, and you use it as a guide for drawing the Bohr atomic model. So for this neutral atom, fluorine, which has an atomic number 9, we know it's got not only 9 protons, but importantly 9 electrons. And we can see that the sum of the exponents, 2 plus 2 plus 5, adds up to those 9 electrons. So this is our correct complete electron configuration for fluorine, and we're going to use it as a guide for drawing the Bohr atomic model for fluorine. Okay, when we do this, we read each chunk of 3 pieces of information. Here's a chunk, here's a chunk, here's a chunk. We read each chunk of 3 pieces of information and we use it as a guide for drawing the Bohr atomic model. For example, this chunk says on the first energy level, I'm going to draw 2 electron dots. So here's my first energy level. And here are those 2 electron dots on the first energy level. Now I move on to the next chunk of 3 pieces of information. This says on the second energy level, I'm going to draw another 2 dots. So here's my second energy level. I need 2 dots. Now I move on to this last chunk of 3 pieces of information, and it says, still on the second energy level, I'm going to draw another 5 electron dots. 1, 2, 3, 4, 5. And this one is unnecessary. So now if we take a look, on this second energy level, we can count up 7 electrons. Said another way, fluorine has 7 valence electrons. Valence electrons are the electrons on the outermost energy level. So we've got 1, 2, 3, 4, 5, 6, 7 valence electrons. It's these 2 on the second energy level plus these 5 also on the second energy level. So this is the complete electron configuration, and this is the Bohr atomic model for fluorine. Let's take a look at another example. If we're talking about the neutral atom aluminum, it has not only 13 protons but also 13 electrons. And you can see when we write the complete electron configuration that the sum of the exponents, 2 plus 2 plus 6 plus 2 plus 1, adds up to those 13 electrons. So again, we're going to use this as a guide for drawing the Bohr atomic model. First energy level, 2 electron dots. Second energy level, 2 electron dots. Still on the second energy level, another 6 electron dots. So there's 1, 2, 3, 4, 5, 6. Now we move on to the third energy level, and we draw 2 electron dots on the third energy level. 1, 2. Now we're still on the third energy level, and we draw another 1 electron dot on that third energy level. Now to reinforce some other concepts that we're learning, if you take a look up here, you can see that the third energy level has 2 plus 1. It has 3 valence electrons. Here's 1, 2, 3 valence electrons, and we would find aluminum in main group 3 on the periodic table. All right, let's take a look at one last example. This example here is aluminum, but this example here is aluminum ion. Notice that it has a +3 charge. You should ask yourself if that means that it's gained or lost 3 valence electrons. When aluminum turns into aluminum ion, it loses 3 valence electrons to take a +3 charge. So it no longer has 13 electrons. It's got 13 minus 3, which is 10 electrons. So we actually need to remove those last 3 electrons. And so this is the electron configuration for aluminum ion, which now has 10 electrons. All right, so let's use this as a guide for drawing its Bohr atomic model. First energy level, 2 electrons. Move this one up there. Second energy level, 2 electrons. Still on the second energy level, another 6 electrons on that second energy level. 2, 3, 4, 5, and 6. Okay, so let's take a look. We can count that aluminum ion now has a total of 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Supporting the concept that we've learned that when atoms turn into ions that are in the 8 main groups on the periodic table, they want to gain or lose the fewest number of valence electrons possible to get to a stable octet of 8 valence electrons. And the 8 valence electrons that this has are the 2s2 valence electrons plus the 2p6 valence electrons. We can see those 8 valence electrons on the second energy level. Okay, hope this helps you to draw electron configurations and the corresponding Bohr atomic models. Thanks guys, see you soon.